Yeah. Okay. So we are moving on to the first inertial mass. So before we go to inertial mass, now Rin, can you tell me what you mean by law inertia? We have learned laws of motion chapter. What do you mean by inertia?
An object remains in the state of rest or state of motion unless an unbalanced external force is applied.
Yes. Okay. Okay. Aditya, what is the Newton's second law? What is the Newton's second law?
Ma'am, F is equal
Because
to
last
ma.
class also asked F is equal to ma. Okay. So inertial mass is the mass of the earth. When you don't write now, I'll explain to you. So we have two type of mass. We can divide it earth mass itself, inertial mass and gravitational mass. So don't think inertial mass is something is a different quantity, gravitational mass something is a different quantity. It's not like that. Clear? So by Newton's second law, we have the equation that is force is equal to mass into acceleration. Similarly, we also have the equation of gravitational force. Yesterday we have learned. Okay. Vidur, can you tell me what is the gravitational force equation? What we have learned in last class? Can you tell me that? F is equal to what? Last class we were discussing F is equal to, it is the attractive force. Every object in the universe attract each other with the force. Using that statement, can you tell me that equation? What we have learned yesterday? At least you don't know, at least you must have written on the book. Please tell me that, Vidu. Tell me that.
F is equal to mv by r square.
That is centripetal force, gravitational force. You are not written that important equation we have learned. Mass is directly proportional, distance is inversely proportional. Do you remember that factors? What's that equation? At least you can just read now. If you can't read, everyone.
F is equal to
Okay.
G.
I give 1 minute. Everyone just pass. G. Come. Hurry up. G.
M.
While I am asking your others just to go through that points, what we have learned. F is equal to G. Masses of two objects. G into
capital M small m
G
by r square.
Divided by r square. Okay. So that is the equation for gravitational force between earth and any object. Otherwise, first we have learned it is Gm1 m2 by r square or Gm1 m2 by d square. Okay. So that is the gravitational force of equation. So according to Newton's second law, you have one equation that is force is equal to mass into acceleration. Similarly, can you tell me the equation of the weight? Weight. There also you will get equation F is equal to dash. Anyone remember that one? Weight equation. How can you find out the weight of an object in 10 kg? If you want to find out the weight of that object, what you should do?
F is equal to mg.
What you should do? Correct. Then F is equal to mg. So these all are various equations to find out the force. But F is equal to mg, and that is also is equal to F is equal to Gm1 m2 by r square. So F is equal to mg and Gm1 m2 by r square. That we can from that you can find out the gravitational mass. Now inertial mass means whenever an object is rotating, it is producing an acceleration. Correct. So on the basis of that, we are getting equation F is equal to ma, and according to first law of Newton's law of inertia, that a body remains in state of rest and state of motion until an external unbalanced force applied. So by using that equation, if you are finding a mass of an object, then we call it as inertial mass. I repeat once again, by using Newton's second law, F is equal to ma. If you are able to find out the value of mass, can you tell me from F is equal to ma? F is equal to ma. In that, can you give me the answer for m from that same equation? F is equal to ma. Therefore, from this equation, what is m? What is m from this equation? Is equal to ma. Therefore, m is equal to what? Just
F by
manipulation
A.
of that equation only, no? Correct. F by A. And if you are using this equation, finding the mass of an object, we call it as inertial mass. Okay. So don't write now. I'll give you the definition of inertial mass, and we can write this equation. Okay. So write down. The mass of an object can be defined as the amount of matter contained in a body. Contained in a body. Now, next line you can write by Newton's second law. Newton's second law. You write how to use. That's it. According to Newton's second law, when a force F acts on a body, and acceleration is produced. Capital F is equal to small m into A. Therefore, A is equal to capital F, sorry, not A, we are finding mass. So F is equal to capital F divided by small a. Okay. Then below that you write hence the mass of a body or an object, a particle, same mass of a body, hence the mass of a body is measured in this manner. Is known as inertial mass. Why in this there is no term of gravity here. Here it is only the terms are in terms of acceleration. Acceleration means a moving body in a stream. Correct. So that is why it is known as inertial mass. Now, gravitational mass, I told you, F is equal to G/mm by R square. From that you can find small. Capital M is mass of here. That's the standard value. Suppose you have to find out the mass of an object, maybe mass of U, by using equation of gravitational force. In that case, we can use that equation. Equation one is F is equal to mg. Another equation is F is equal to g mm by r square. So, in that manner, you are finding the mass of an object. We call it gravitational mass. But both the values are same. This m also same, that m also same. But we are calculating the mass of the object in different situations. In different situation, this inertial mass in terms of one-dimensional motion and gravitational mass in terms of two-dimensional motion. That is the difference between both of them. But mass is same. There is no change in mass wherever you go, either in the moon, either in the Mars, either on the Everest, Mount Everest. You will not have any changes in your thing. Okay. So next heading we can move on to gravitational force. Next we are moving on to gravitational force. Sorry, not gravitational force, gravitational.
Ma'am, yeah, it is gravitational mass.
Mass. Yes, gravitational mass. Gravitational mass. So you can write down from the law of gravitation. From the law of gravitation. From the law of gravitation. We have force acts on a body, force F acts on a body. Capital F is equal to G, capital M into small m divided by capital R. As a superscript, you write R square. Okay, I'm writing R2. R2 means R square, please. Okay. Then next line you can write, therefore, from this we have to find out M. Can you tell me? Small m is equal to what? You do by yourself. What equation you will get? G mm by R square. Yes?
F R square
Atul is telling. F R square, okay.
by G N capital M.
Divided by
G N capital M.
Correct. G means, yes, correct. G is gravitational constant, M is the mass of the earth. So this is how you find out gravitational mass. F R square. Don't write R2, it is F R square. Okay, below that you can write the mass of a body, is measured in this manner. We call it as gravitational mass. We call it as gravitational mass. We call it as gravitational mass. Okay, so that is our term. Next we are moving on to principle of superposition. Next term related to gravitation. We are going to principle of superposition principle of superposition, because we are already what is center of mass. So if you just think about Earth is attracting every object toward the Earth. So it is a system. So Earth is as a rotational system. So that is what we have learned in the last chapter. So that means center of the mass of entire particles, entire objects on Earth is concentrated at the center. Correct. So we are the objects, we are the particles on the surface of the Earth. We are the particles on the surface of the Earth. That means each one of us experience a gravitational force individually. So my weight is 70 kg. One of you maybe can say the smallest boy in your class have small weight, may have Aditya or maybe Sri Hari. These are the people may have less weight than me as compared to others in your class also. So in their case, the Earth is attracting Sri Hari, Vidur. All these people is different. The different gravitational force according to their weight. That means suppose Vidur has a weight of 60 kg. Then Earth, you attract Earth. They both of them attract the Earth with their force. That means 60 kg means 600 Newton. And Earth also attracting you with the same 600 Newton. Because Earth did not want you to have more force because you are very small. Okay, each one of us. Similarly, my weight 70 kg. So I am attracting Earth with 700 Newton. So Earth may attract me with the 700 Newton, maybe more than that. But still, because of the Newton's third law, 700 equal and opposite get cancelled. So that's what we are able to sit here. Okay. And your life is stable. Okay. So in that cases, Earth is a rotational system. It also experiences translation motion. If you draw the tangent and it is explained rotational motion, that means it is about the axis of rotation. It rotates about the axis of rotation and as well as it is moving around the sun at the same time. Okay, therefore, entire mass of the Earth or entire mass of the particles will be equal to the entire mass of the Earth. Entire mass of the particles, that means we, the trees, animals, birds, including everything in this universe. Entire mass of the, not universe, world. Universe means even included planets and others. We are world. Universe is that. So entire world is should be equal to the entire mass of the Earth. And our entire mass of every particle in this world is concentrated at the center of mass of the Earth. Clear? Therefore, principle of superposition states that total, don't write now, total mass of particles on Earth will be equal to the vector sum of the, in the case of masses, it's a scalar quantity. In the case of forces, it will be vector. So entire mass of the particles on the Earth will be total mass of Earth capital M is equal to M1 plus M2 plus M3 plus etc. up to Mn. Similarly, total gravitational force of this entire particles will be equal to capital F is equal to F1 plus F2 plus F3 plus up to Fn. How many particles? So this is known as principle of superposition. So total mass of the Earth also will be equal to the sum of individual mass of the particles, mass of the object on the Earth. Similarly, gravitational force of the Earth mathematically equal to the vector sum of individual gravitational force of every object on the Earth. So that is known as principle of superposition. Okay, and this principle of superposition is applicable in every branch of physics. When you go to +2, so we will study +2 by February that time. we are starting with the chapter electricity, electrical charge. In that also superposition principle comes. Also we learn a chapter of rayotics. In that also superposition principle comes. In every branch of the physics, superposition principle is applicable and quantities. Now we are discussing gravitation. Therefore, here we are talking principle of superposition between the objects and the earth. Got it? Yes. So I think you are able to see me now. Okay. So you can write it now. Next line under that expression for that. Suppose you can write. Suppose a number of bodies of masses. Suppose a number of. Can you see the screen?
Yes.
Can you see the screen, children? Okay. Okay. Suppose a number of bodies of masses small m suffix 1. So m, comma m2, comma etc. are exerting gravitational forces on earth or a single object. So it is not only between earth. Maybe now one of you I am here, all the objects surrounding my area, it is accepting a gravitational force on me also. So in that case also superposition principle is satisfied. It is not necessary earth also. Okay. M1, M2, M3. So here there's a table, there's a chair, everything. They are trying to attract me. So that is what single or a single mass. Okay. Forces on earth or a single mass of an object. Then resultant gravitational force. Resultant gravitational force. F, capital F is equal to, put vector sign on the top of F. Vector sign on the top of F means you know the arrow with the line. I cannot draw, you can do it. So on the top, vector sign, then F suffix 1 plus F suffix 2 plus F suffix 3 plus etc. On the top of every force F1, F2, F3, you put the vector sign because it's the vector. Okay. So that is principle of superposition. Okay. So that means it's not necessary that it is on earth also. It can be a single object like you. Achyut is sitting there. So there are so many objects around you. You are attracting them and other objects are attracting you. So individual force, they are acting on you. That will be equal to the resultant gravitation now. So that's the meaning of this superposition. So that is the same in every person's object, solid, liquid, gas in the world. Okay, any particle. Okay. Okay, children. So we will meet at 11:30. Hope so. My network will be okay. Thank you. I
Thank
end
you.
the meeting now. Okay. Thank you.